Okay, grade 8s. Here is the Unit 4 notes, Topic 3, Energy, Friction, and Efficiency. Okay, and so we went through some formulas. Work equals force times distance, but once again, force is mass times acceleration. So you can get a derived formula, work equals mass times acceleration times the distance. Okay, and so as you know, there's lots of different kinds of energy, and energy cannot be created, but it can be converted from one form to another. You can also transfer energy from one place to another. This is called transmission. And so kinetic energy, here is energy of motion. There's the formula up top here. Kinetic energy equals 1/2 mv squared. So for example, the transmission of energy from a pedal on a bike to the sprocket and then to the wheel and axle, that is the movement of energy. Potential energy is the stored energy. Now this is gravitational stored energy. Mass times acceleration due to gravity, which is 9.81 meters per second, times the height in meters. We can also store energy in rubber bands. Potential energy could be stored in chemicals. There's all kinds of ways to store. Well, I suppose that's called chemical potential energy. There's other ways to store energy. And so friction occurs when two objects rub together. So when the force is pushing this way, there's an opposing force called friction. It results in energy loss, usually lost to heat. Okay, so when is friction useful? It's useful for brakes and cleats, for warming up your hands. It's useful for holding things. It means you could walk and not slip. We use it in sports. Okay, and when is friction a problem? If you get excessive heat, air friction for airplanes and cars, you need to sharpen your skates, otherwise there's too much friction and you can't skate very well. In any sort of machines, metal to metal contact is problems with friction. And efficiency is expressed as a percentage. It's used to describe the energy transmission in a machine. It tells you how much energy is lost due to friction and how much is transferred to load. Can a machine ever be 100% efficient? Nope. And so if you do your efficiency calculation and you end up with more than 100% efficient, you put your numbers upside down. When I do efficiency calculation, I just go small divided by big times 100. And how do we increase efficiency? Well, we could add a lubricant, so grease or oil. On a car, we could keep our tires inflated so that there's less contact with the road in that sense. We could make sure we change all our fluids so that there's less friction within the engine as well. And we were talking about 32 psi. That is kind of the standard for tire inflation on a regular tire. But you would always check the side of your tire to find out for sure what is recommended inflation. It's also on the inside door sticker of your car. Calculating efficiency is output divided by input times 100. So here we have an example. 40 joules of work is supplied to it, does 30 joules of useful. Small divided by big, 30 divided by 40 times 100. Or if you want output divided by input times 100. Remember, you can never have more than 100% efficiency. So like in this case, when they did it wrong, they got 133%. Impossible. And then we did some more calculations with this, okay, and a little bit of work with pressure as well that we've done earlier. And force, area, pressure, and area. So let's go ahead and look at this. This is topic 4. Okay, and so remember, pressure is force over area. I taught you how to go from here to create this. You are responsible for being able to manipulate the formulas. And we looked at Pascal's law. That's pressure exerted on a contained liquid is transmitted in all directions throughout the liquid and perpendicular to the walls of the container. In other words, if you apply pressure to a liquid in a container, the liquid will transfer that same amount of pressure in all directions. And here are some examples of hydraulic system, a hydraulic lift. Okay, and basically in this hydraulic lift, the pressure is the same throughout the container. So you can actually change the force by changing the area of the cylinder. And this is the formula that governs that. Force divided by area, the small side, that's this side, equals force divided by area, the large size. So if we make this, so I'll show you in the calculation. Okay, and so there's the formula again. Okay, so in this diagram, it's pushing with a force of 10 newtons, generates a force of 10 newtons per area. In the larger piston, there's 9 units of area, so that 10 newtons is applied to 9, you end up with a 90 newton advantage. And then we did some calculations and some practice. We did more practice. And then in this case, to figure out mechanical advantage, if you put in 10 force input and then 90 is the output, 90 divided by 10 gives you mechanical advantage of 9. And then that was the end of topic 3 and 4.